and welcome to Math Made Simple. My name is J.Akoi. If you have not already subscribed to my channel, please consider doing so that you will receive notifications whenever I upload new contents. Please also like the video and make comments below. In our previous lesson in a function series, we talked about the operations of function. We talked about the addition, subtraction, multiplication, and division of function. And we also solve example problems. If you want to follow up on that lesson, please check out the link in the description below. In today's lesson, we will talk about composition of function and inverse function, and we will also solve relative sample problems. Composite and inverse function. We say composition of function is applying one function into the result of another function. It is usually given in its form, and which is read as f of g of x. So we say for this function, if the inner function g of x equals a, then f of g of x will equals f of a. Replacing the inner function g of x with a, then you have a new function f of a. So we say that there are 4 basic steps in solving composite function problems, as we will go through right now. 1. First, evaluate the inner function. Then the second step is replace the inner function with the value obtained from step 1. Thirdly, you evaluate the resulting function from step 2. And equate f of g of x to the result from step 3 as your final answer for the problem. So let us do some example problems so that we have a clear understanding on this. So number 1, if f of x equals 2x plus 3, g of x equals x squared, find a f of g of minus 3, b g of f of minus 2. So solution. A. Step 1. So let us follow the 4 steps as we outlined previously. Step 1. And what step 1 says? Step 1 says, first evaluate the inner function. So the inner function here is g of minus 3. So we will evaluate this. G of minus 3 will equals minus 3 squared, because the g function is x squared. So minus 3 squared. Minus 3 squared is minus 3 times minus 3, which will give us 9. So after evaluating the inner function, we obtain 9. So what step 2 says? Replace the inner function with the value obtained from step 1. So our value obtained from step 1 is 9. So we replace this inner function. So we now have f of g of minus 3 now will become f of 9, replacing the g of minus 3, which we obtain from step 1. And step 3, evaluate the resulting function from step 2. So we evaluate this function, the new function, which is f of 9. So step 3 now, we evaluate that f of 9. We have 2 times 9 plus 3, because the f function says 2x plus 3. So where you see x, you replace it with 9. So you have now f of 9 equals 2 times 9 plus 3. 2 times 9 is 18 plus 3 is 21. So 2 times 9 plus 3 is 21. So our f of 9 is 21. Then step 4 says equate f of g of x to the result from step 3. F of g of minus 3 equals 21. So this becomes our answer for this problem. B says g of f of minus 2. So what we would love to do is to evaluate the inner function, which is f of minus 2 equals 2 times minus 2 plus 3, which is from the f function. So we have 2 times minus 2 is minus 4 plus 3. Minus 4 plus 3 is negative 1. So we replace the inner function, the g of f of minus 2. So we place f of minus 2. So we have now our new function g of minus 1. So we evaluate g of minus 1 using the g function. So we now have g of minus 1 equals minus 1 square. Minus 1 square is minus 1 times minus 1, which is positive 1. So therefore, our g of f of minus 2 equals positive 1, which is the answer to this problem. So let us look at problem number 2. If f of x equals 2x to the 4th power plus x squared plus 1 and g of x equals the square root of 2x, evaluate f of g of x. Then B says find the domain of the composite function. Solution: A, f of g of x. So what we will do is to evaluate the inner function g of x. And g of x is simply square root of 2x. So what we do is to replace the g of x with the value we have for g of x. So that becomes f of root 2x, our new function. So now we use the f function and evaluate f of root 2x. So you have 2x to the 4th power. So it becomes 2 root 2x. But we know root 2x is the same as 2x all raised to the half power. So 2x raised to the half power all raised to the 4th power plus 2x raised to half power square plus 1. So 2x to the half power is the same as root 2x. So we do that evaluation, keep our 2 out, and 2x to half power to the raised to the 4th power, half times 4 is 2. So we have 2 times 2x raised to the 2 power plus 2x, because here 2x raised to half power all raised to the 2 power, half times 2 is 1. So you will have 2x plus 1. So 2 multiplied by 2 square is 4, x square is x square plus 2x plus 1. Then you have 2 times 4 is 8, x square plus 2x plus 1. This becomes our answer to this problem. Then let's look at B. B says find the domain of the composite function. Now, in finding the domain of the composite function, you will love to find the domain of the inner function and also find the domain of the outer function and find the intersection of those two sets. That would be the domain of the composite function. So we go right ahead and find the domain of g of x, which is the inner function. Now, since we have x, 2x as a square root, you wouldn't want for x to take on any negative value because the square root of a negative number is an imaginary number. So you wouldn't want to have x taking on any negative value. So the domain for g of x will be x is a set of all real numbers such that x is greater than or equal to 0. So x can take on the value of 0 and it can take on any positive real value, but not negative numbers. So that would be the domain for the inner function g of x. And the outer function, which is f of root 2x, that would be this equation. What would be the domain for this equation? If you see this equation, x can take on any real number. So we say the domain for f of root 2x would be the set of all real numbers. So what we would do is to find the intersection of these two sets. And the intersection of these two sets is just simply x is a set of all real numbers such that x is greater than or equal to 0. So it means the domain for the composite function f of g of x will simply be x is a set of all real numbers such that x is greater than or equal to 0. Now let's look at the inverse function. If f of x is a function, then its inverse is f inverse of x. A function and its inverse have a reverse relationship, like we will see in this illustration. If we have an input, which is the domain, into a function, which is the machine, that is going to do all of the workings in dealing with the domain, and it sends out an output, which we call the range. So let's take, for instance, we have 2, 4, and 6 as our input values or the domain. And when we use those values into this function, which is the machine, it's going to send out this respective output value, A, B, and C. What's happening if we want to obtain the domain for the original function in another function? So what will happen is we will now have a second function, which was now the inverse of the first original function. So what the inverse function does is it takes the output value or the range of the original function, use it now as a domain of the inverse function, and then that inverse function will do a reverse process. It takes that domain back to its original form, which will now be called the output or the range. So the A, B, and C, which were the range for the original function, will now be used as the domain for the inverse function, and will produce 2, 4, and 6 as now our new range, which is now the output value for the inverse function. So this is just simply what an inverse function does. So we have series of inverse relationships, and some of the most common ones will be listed as the addition and subtraction, and the multiplication and division. For addition and subtraction, if, for instance, you have 5 plus 3, which is equals to 8, if 5 is the domain and the function is x plus 3, and you place 5 in the x plus 3, you are going to get 8, which will be the range. If you reverse this process, it means you will be using now the reverse relationship to addition, which is subtraction. Then if you use that now as the domain in this reverse function, you have now 8 minus 3, which will give us 5, the domain of the original function. Then if you look at division and multiplication and division, likewise, you use 5 as the domain, 5 times 3, meaning x times 3 will be our function, and you place 5 in it, you're going to get 15. If you do a reverse of that, will be 15, using now 15, which is now our domain, and dividing by 3, we will have 5. So this is how basically inverse functions behave. They do a reverse process to the original function. See, we also have few steps that we follow when we are solving inverse function problems. And number 1, we say replace f of x with y. And 2, interchange x and y in the problem. 3, solve for y in the equation from step 2. And 4, you have replace y with f inverse of x problem. So example problem number 1, we say if f of x equals 2f(x minus 5, find the inverse function. Solution. So our function, our original function is f of x equals 2f(x minus y. Looking at the steps, the first thing we would love to do is to replace f of x with y. So you have step 1, y equals 2f(x minus 5. Because you have f of x equals 2f(x minus 5, you replace f of x with y. So you have this equation. This is now a linear equation. 2, interchange x and y. So where you see x, you put y. Where you see y, you put x. So we have y here, we put x. We have x here, we put y. So now in this new linear equation, step 3 says you should solve for y. So we are going to make y the subject of the equation. So in making y the subject of the equation, which is now step 3, you will transpose this minus 5. It becomes positive 5. So it's x plus 5 equals 12 y. So you divide both sides of the equation by 12. You will have this value. Then step 4 says replace the y after solving for y. Replace y with f inverse of x. So you now have step 4. F inverse of x is equals to x plus 5 over 12. This becomes our inverse function to this function. Number 2, given f of x equals 3x squared plus 5, find its inverse function. Solution. F of x equals 3x plus 5. So you remove f of x and replace it with y. So it becomes y equals 3x squared plus 5. And you interchange in the next step, you interchange the variables. So you have x now equals 3y squared plus 5. Then the next step is to make y the subject of the equation. So we make y the subject of the equation. So we have x, this 5 is transposed. So it becomes x minus 5 equals 3y squared. Divide both sides of the equation with 3. So you have x minus 5 over 3 equals y squared. And you find the square root. You find the square root. And square root is the same as the number raised to half power. So you have x minus 5 raised to half power over 3 raised to half power as our y. So the last step now is to remove y and place in the inverse function. So it becomes f inverse of x equals x minus 5 raised to half power divided by 3 raised to half power. That is our answer for the problem.